I'm going to, in this video, we're going to talk about how we compare these four forecasting techniques using MAD, mean absolute deviation. The only way to really tell which of these four forecasting techniques is the best is to determine which has the least amount of error. And we do that using MAD. Now we'll introduce in class a couple of other techniques. One of them is called mean squared error, where you square the errors. That has some mathematical properties, and in statistics we like to square errors. The other one is mean absolute percentage error. And there's some advantages to that if you're comparing different things. In this case, we're only comparing all four forecasting techniques were used on the same type of data. But we'll explain those other forecasting techniques to you in class. The one you need to know, and the one that in comparing, when you have one set of data and you have four different techniques, we'll always use MAD, mean absolute deviation. And all it is you compare the forecast to the actual to see how much of an error, and then you calculate what the error is. Now we absolute it because sometimes your forecast will be above the actual, in other cases will be below. And so if we had positive and negatives, they would cancel each other out, and it would seem like you had no error. We want to avoid that, so we absolute everything. So even if your forecast is higher than the actual and would give you a negative number, we're going to absolute that so that we always just determine how big of an error it is. It doesn't matter whether you're above or below. And then we'll figure out the average of those errors. So what I'm going to do is I'm going to go here, and we could actually calculate the error for February and March with a naive approach, because we have both actual and forecast. And we could do that over here for exponential smoothing as well. But in regards to make the comparison fair for all of these techniques, we want to only compare those ones where we have a forecast and actual across all the techniques. So I'm going to do this in April because I have that for the naive, the average, the weighted average, and the exponential smoothing. And so to absolute something in Excel, we use a function called ABS. That's absolute. And then we're going to simply take the forecast minus the error, or I'm sorry, the actual minus the forecast. So what the difference is between the actual and the forecast, and then we're going to absolute that. So when your forecast is bigger than your actual, and you get a negative number, the absolute will change it to a positive number. And so we simply have the error. So we were off 3 sheds for the naive approach, and so we can copy this down. And we're only going to copy it down to December because we don't have actual sales for January, even though we made a forecast. And so here's what I was talking about. This normally would have been a negative number. We would have had the actual minus the forecast, and that would give us a -2, but we absoluted it, and so we get a 2. Now all we have to do is go down here and you equal average, because we want to know the average error. So we vary from 2 all the way up to 10. We were really off in October. But we average these numbers together, and so we can say that the average error for the naive approach, we on average have an error of about 4 sheds, 3.6 sheds off. Now let's go ahead and do that for the moving average. So same thing, ABS, we will take the actual minus the forecast to see how far we're off, and we will do that for the months we have actuals and forecast. And then the same thing, we want to know what the average is of these numbers here. So right now this technique is looking far better. The naive approach, because here our average error is a 6 sheds off, where we're 4 sheds off here, 3.66. So between these two techniques, this is the better technique because it has a less error. Let's keep going through and seeing about the other techniques. So ABS, absoluting the difference between the actual minus our forecast. So how far we were off, and we want to absolute that. We'll copy that down to December here, and then we will calculate then the average of those errors. What's the average of each of those errors? So you have to calculate the error for each time period that you're doing. So it's a little bit less of an error than the 3-month moving average. This is the weighted average, so it's doing a little bit better job, but still not doing as good job as the naive approach. Last one, we'll compare. Like I said, you could have gone back up here and done it for February and March, but to include those 2 extra months when we don't have those for the weighted average or the regular average, the moving average. So we want to make sure we compare the time periods that are the same, but absolute, and then we want to make sure that we go April minus the actual minus the forecast, close parentheses, and then let's copy this one down, and let's figure out then the average for this equals average, oops, and we'll average these together. Let's double check to make sure that these are doing it correctly. So we absoluted the difference between this one and this one. This would have given us a negative number, 16 minus 23. But we changed it into a positive because we absoluted it. And so we wind up, so out of these 4 techniques, the best one and the simplest and cheapest one is to use the naive forecast. Given the data and the way it goes up and kind of down, the naive seems to do the best job at capturing, or in regards to it has the least amount of error, where the moving average has the most amount of error, followed by exponential smoothing, and then the weighted average, but this one seems to give us the best. So if we had to look at these 4 techniques, we would say the naive is the best because it has the least amount of error given MAD. Now we'll talk about, there's 2 other forecasting techniques that we need to talk about, and that's the regression with time periods, and then the associated forecasting, which is also regression with but they have better techniques to compare how accurate they are, and so we don't tend to use MAD on those techniques because there's some built-in techniques into regression that shows us which of the techniques is better. So